Okay, video number 2. I cut the other video off a little soon because the computer was acting a little strange. Hopefully I've cleared out some stuff and it'll work better. It seems to be. First of all, the handout that I'm going to work now is this with practice problems, 4 practice problems. The first 2 are kind of challenging, the third one's straightforward, and the fourth one actually gets into something new called exponential equations. So I'm going to teach you all about that, and, which, you know, pretty cool. Linear functions and exponential functions are 2 of the most common that we run into in mathematics of finance. So guys, let's go for it. The first problem, you know, just glance through and you can see that it deals with the supply and demand. And let me tell you a little bit about supply and demand. These 2 functions work kind of in opposite directions. And what you can expect is if you know, a producer is asked to produce more stuff, more widgets or whatever it may be, they're going to be more likely to do so if they're given more money. So the supply, the amount produced, is going to go up if we let me go back over here. Okay, so the supply is going to go up. Let's look at X and P on the horizontal. So the supply line is going to look like this because producers are going to be willing to produce more units at a higher price. The demand function, on the other hand, is going to have a negative slope because consumers are going to you know, require less well, I say that as anyway, in the simplest case imaginable, consumers are going to buy less as the price goes up. Now, we all know that there's a in purchasing, there's a psychological component. You know, for example, the Beats headphones. I wonder how many they would have sold. I don't know. I'm talking about something I know nothing about. But anyway, guys, when we look at our supply demand function, you know, this is what we get. Supply function has a positive slope, again, because producers are willing to produce more you know, stuff, the more price that they get. And the demand function has a negative slope because consumers are going to purchase less as the price goes up. And you know, people love to make the price of gasoline into a political discussion. In fact, I heard some people talking this weekend. This weekend was Memorial Day, that the price went up because Obama wanted to put the price up. Well, that's a little silly. Obama doesn't control gas prices. What the gas prices are set on is supply and demand. They know that a lot of people are going to drive on a holiday weekend, so the price goes up, hoping that the demand will go down. They're hoping to control the demand for gas, and they do so by raising the price. During the week when the demand's lower, price goes down, you know, hoping to increase the demand that what people are going to buy. Anyway, guys, this point of intersection right here is called the equilibrium point. And at the end of the day, the equilibrium point is a phenomena in economics where the supply is equal to the demand. So let's get in and get our hands dirty here. Okay, so when we deal with the price supply, and price demand, what we want is we want our price to be our dependent variable and then our supply to be as a function of the quantity. And we'll use this, actually, we'll use our, well, I'll tell you what, let's keep this simple here. Believe it or not, guys, I'm always trying to think about, well, from the student perspective, what would be the easiest. Over here, the price demand is also going to be a function of x. Okay, so let's get our hands dirty. So guys, at the end of the day, our ordered pairs are going to be the quantity, and the y value will be the price. Now, I think in starting any problem, what I would want you to do is take all the words in the problem and put it in kind of a compact form where it's going to be easier to read. Now, if you look at the handout says at a price of $1.88, the supply for cherries is 16,000, and the demand is 10,600. When the price drops to $1.46, the supply decreases to 10,000. Why? Well, producers aren't willing to produce as much when they don't get as much for it. And the demand increases to 12,700. Now, why is this value increasing? Well, the price went down, and people are willing to buy more. Why did this go up this way? Well, we increased the price, so manufacturers are willing to produce more. Now, from this phenomena, we're going to create ordered pairs. And what I want to do, I want to let our supply and demand, you see this a lot in these types of problems, be in thousands. It's just going to simplify the calculations. So let's do this again. Price, supply, demand. So I have $1.88. The supply was 16,000, so I'm just going to use 16. And the demand was 10,600, so I'm going to use 10.6. When the price drops to $1.46, the supply decreases to 10,000, and the demand increases to 12,700. So that'd be 12.7 thousandths. Now, let's look at some ordered pairs, and let's just divide this supply side, demand side. So from the supply side, we see that let's see, supply, I'm getting a phone call here and I don't want to take it because, so we've got an ordered pair 16 for $1.88. And then when the price drops to $1.46, the supply was 10,000. Now the demand part of it, when we had $1.88, the demand was 10.6. And when we had $1.46, the demand was 12.7. I'll tell you what, hold on just a second and let me text this person. They're about to go insane here. Okay. Now, first thing we need to do is, is come up with the functions. So I'm going to do the the calculator for this because I think it's the calculations are going to be a little messy. So the first thing I'm going to do is go to Stat, and I want to go to Edit. And for the supply, I have 16 and 10. And I have 1.88 and 1.46. Okay, so just like we had on the blackboard. Now, just like we've done before, stat, calc, linear regression. It's kind of cool there because we're always going to use L1 and L2, and that's what will be there. So guys, just come down to calculate, go for it. And we can see that the supply function is going to be, okay, so it's going to be P equals 0.07x plus 0.76. You guys, I'm writing this over on the blackboard, so we'll have it when we go back over there. All right, let's go back to Stat, go back to Edit. And all we'll need to do here is take care of our x's because our y's are going to be the same. So we're going to need 10.6 here. And we're going to need 12.7. Okay, same thing, stat, calc, number 4, and come all the way down to calculate. So our demand function is actually not going to be that crazy either, so we're going to have our demand function P equal negative 0.2x plus 4. All right. Now I'm going to go back to this, and you can see that I've written everything down. Okay, so if you go back to your handout, there's 4 parts to question 1, A, B, C, D. So for 1A, which asks you to find the price supply function, well, that's just going to be 0.07 and 0.76. Alrighty, part B is the price demand. And what was that? Negative 0.2 and 4. Now, part C, find the supply and demand at $2.09 per pound. Now, what I want to do now is I want to get out of the blackboard and go back to the calculator and show you some stuff that's actually going to get us ready for some things later in the class. Now, what I want you to do, I want you to go up to y equals, where we can graph. And I want to put both of these functions in. So I want to put 0.07x plus 0.76. You guys remember, if I'm going too fast, pause me. And the next thing I want is negative 0.2 plus 4. Now, what I got to do next is I've got to come in and set the window where it's going to make sense for this problem. Now, if you think about our x's in this problem, they have to do with the cherries in thousands. And the values that we've been given are 16,000, 10,600, 10,000, and 12,700. So I need to run the cherries, it looks like, from the lowest we have is 10,000. So I'm going to start this a little bit below that at 5,000. Remember, we're given things in thousands. And then we've got the biggest thing we have is what, 16,000. I'll tell you what, I'm just going to go a little bit above that and go 20,000. Now my y's in this situation, guys, always choose 1 as X scale. My y's in this case deal with the price. And the prices are $1.46, so I'm going to go, now I don't know, $1, something below the lowest. And hold on. And the highest I have is what, $1.88, so I'm just going to go to 2. So $1 to $2 takes care of my $1.46 and $1.88. Now I'm going to come up and go graph. And that's just lovely. All right, here's what's happened more than likely. What's happened is our stat plots are probably turned on. So if I go up here to second function stat plot, and I notice I've got one of those on, if I'll just hit the number 4, because look what 4 is, plots off. Number 4 will just turn all the plots off. So hit 4, hit enter, and I'm done. So now I've turned all my stat plots off, so I shouldn't have a dim mismatch with my graph. And it turns out I don't. Actually, I'm kind of glad that happened. Okay, now part C says find the supply and demand at a price of $2.09 per pound. Well, I'm going to have to use a little bit of algebra here, but I want this on here because for part D. Okay, so I'll come back to this in part D. So let's go back to well, I've lost my kicked me out. Don't understand it. Okay, so part C, what we need is we need to know when the price is $2.09, we need to find the supply and demand. So for the first problem, we're going to use this for the supply. As obviously, we're going to subtract 0.76 from both sides. And we get 1.33 on the left, and we have 0.07x on the right. So guys, divide by 0.07. And we get x equal 19, which remember would be in thousands. So it would take 19,000 pounds of cherries to have a supply of a price of $2.09 per pound. All right, next we're going to do the demand. So we have 2.09. Let's go back and get our demand function, negative 0.2 plus 4. All right, so subtract 4. So we get negative 1.91. Negative 0.2x, and it's 0.2, yeah. So guys, divide both sides by negative 0.2. And we get 9.55. So guys, remember this is in thousands, so if you multiply that by 1,000, we get 9,550 pounds. All right, now part D, we need to find the equilibrium point. And guys, remember the equilibrium point is where the two lines cross. Now, and this is going to have an ordered pair of x and a particular price. So our equilibrium price is going to have a quantity, x, and it's going to have a price. Okay? Now, we can find this two different ways. One way we could find this those of you that like to do things, by hand, is set the supply equal to demand and solve. So remember the supply was 0.07x plus 0.76. And the demand, pretty sure I'm right on that, yeah. Well, pick your poison here, really. I'm going to move all of the x's to that side, and I'm going to move the non-x's over here. So essentially, relative to the x's, I'm going to add 0.2 to both sides. To get 0.27x on the left. And I'm going to subtract 0.76 from both sides to get 3.24. Guys, next step is obvious. Divide both sides by 0.27. And we get x equal 12. Which is actually, remember, 12,000. 12 cherries, 12,000 pounds of cherries. Huge difference. Now, we've still got to find P. So what we need to do is choose one of our functions. And I don't think it really matters, but I'm just going to choose the demand function. I like 2's and 4's. 0.2's and 4's better than the other one for some reason. So now what I'm going to do, I'm going to put x equal 12 in this. Because remember, the price is going to be the same. So it doesn't matter which one we choose because we're finding the price where the supply and the demand are the same. Alright gang, so we got negative 0.2 times 12. And then add 4 to that, and we get 1.6. And remember, this is a price. So guys, at the end of the day, our equilibrium point will be our x, which was 12,000, right? Yeah. And 1.60. The interpretation of the equilibrium price is just going to be the point at which the supply and the demand are equal. And I guess in a balanced economy or a fair open economy, that's I guess that's a goal. And it would make sense that if you're selling exactly what you produce, then you have no inventory and life is good. Okay. All right, gang, number 2, one of the tougher problems that we'll deal with the entire semester. So number 2 says at a break-even point of 500 units, the variable costs were $125 and the fixed costs were $10,000. What will the 501st unit sold contribute to the profit? Now, if you look ahead, let's think about break even. That implies to me that I need a revenue function, a cost function, and then the last sentence which is actually the question for the problem, indicates to me that I need a profit function. So gang, I need all this stuff. Now, what does this information tell me? The break even happens at 500. This part right here tells me that R of 500 must be equal to C of 500. Revenue equals cost when we break even. Now, revenue of 500 equal the cost of 500. But now, if you think about it, we know the cost function, because the cost function says that the variable costs are $125 and the fixed costs were $10,000. So what we can now do is we can use that information to make C of 500 a number. Now, students have told me before, sometimes videos I have to watch them more than once. Maybe this is a case. Maybe you have to do that. Maybe you have to just assume ownership of this is a harder problem. And got to work a little harder. All right, gang, nevertheless, C of 500 is equal to 72,500. Now, I can simplify this by that. But as I have told you earlier, a revenue function has to look like, well, I have no idea why my cues are so ugly today. Has to be price times Q. So we know that R 500 has to be some price times 500, which is 500p. Make any sense? Hopefully, because this stuff is going to replace R of 500. So guys, at the end of the day, we have, yeah. So guys, divide both sides by 500. So the price is being sold at. Students have told me before that they're like, Dr. Dabra, there is no way I would have ever come up with that. Well, you didn't have to. We're working it together. You just have to be able to replicate it. Okay? So the price is $145. So gang, what do we know now? We now know a couple things. We know that our cost function, which is given from the information in the problem, is this. And our revenue function, what did I say, 145 times Q. It's always kind of good to compare these, right? Our cost is 125 per unit, our revenue is 145. You're in big trouble if you find out to get a situation where the revenue is actually below the cost. That's not cool. Anyway, gang, what we could do now is we could create easily our profit function. Because again, remember our profit function is R of Q minus C of Q. We should be able to do that now with no problem. Probably sitting there thinking, yeah, easy for you to say. Okay, so next page. Right, yeah. So guys, your profit function ends up being 20Q minus 10,000. Now, we're finally ready to work the problem. What will the 501st unit sold contribute to profit? Well, so we need to have the profit for the 500th unit, and we need to know the profit for the 501st unit. Now, guys, you should know without any arithmetic, plugging and chugging, whatever, that the profit for the 500th unit is 0. Because, guys, this was the break-even point. Now, let's just go back and check that. Let's go back in our profit function, and let's put 500 in here. So, guys, if you take 20 times 500 minus 10,000 in your calculator, you're going to see that you get 0, which is exactly what you should have got. Now, what we need to do now is we need to put 501 in our function. And we'll see that this is $20. So the 501st unit contributed $20 to profit. Yeah, that's a challenging problem. And again, I didn't ask you to come up with it on the fly, but I'm going to expect you to be able to replicate that. But you'll get some opportunities to try that out. All right, number 3. This is going to be much easier than the first 2 problems. So a producer of DVDs is producing an instructional DVD. She estimates it will cost $90,000 to record it, and $5.10 per unit to copy and distribute it. So guys, that's telling me that the cost function is $90,000 plus $5.10 per unit to copy and distribute. Okay, the wholesale price is $14.70. So we'll just call this the revenue function. Now, how many DVDs must be sold for the producer to break even? Well, guys, all we need to do now is just set each side equal to each other. I would subtract 510Q from both sides. So I'm going to get what, $9.60 Q equal 90,000. So grab your calculator. So we get Q is 9,375. So 9,375 units to break even. All right, gang. Number 4. Number 4 comes in, gets into something new. Called an exponential function. Now, if we have a function like this, notice the x is just multiplied by the 3. It's not an exponent. However, if we had something like this, the x would be in the exponent, so we would call this an exponential function. Obviously, gang, we would call that a linear function. So anytime we get the variable in the exponent, we have an exponential function. Now, what about this? Is that an exponential function? No, it's not. We have an exponent, but it's a number. The variable x has to be in the exponent to be an exponential function. If you got a number there, we just call this a cubic function. Okay? So it's not an exponential function. So not, yes, no. Now, the form that I'm going to teach you for exponential functions is just y equals a times b raised to the x power. Guys, a and b, just numbers. They can be nice numbers like 2s and 3s and 4s, or they can be numbers like, 0.76 and so on and so forth. Okay? Guys, exponential functions behave this way. Whereas a linear function makes what we call a straight line, an exponential function will make a line that looks like this. Exponential functions also look like this. So they're not linear, and they are increasing or decreasing everywhere. Okay? Now, let's get into the problem. So the problem says, and this is a classic type of problem to work with an exponential function when we look at the value of a vehicle. I mean, we've all heard that, you drive a car off the lot, it decreases 10%. A car doesn't decrease linearly. It decreases what we call exponentially. So let's get into it. So the market value V of t of a hybrid sedan, t years after it is purchased, can be modeled by an exponential equation. So guys, when you read exponential equation, what you need to think is I'm going to use this thing. Okay? Market analysis shows that the sedan's value 1 year after purchase is $15,000. It also shows that 4 years after purchase, the value is $6,500. Now, if you want, I don't really mind, thousands and 10,000, 100,000s are a little different. You could, if you want, to express this in terms of thousands and do your calculations that way. Guys, I'm going to use this form. This form would be perfectly acceptable. You just have to remember in the end that the values you get for the price are actually in thousands and not just, it'd be kind of goofy to have a car with $15 after 1 year. I guess it's possible, but I don't think I'd want to own it. So, all right, gang. So here's what we've got. We've got just to get a picture here. So we've got time, and we've got the value. So we know 1 year after the car was purchased, it was worth $15,000. And 4 years after it was purchased, pretend there's a point right there. There we go. 6.5 thousand. Now, if we wanted to fit a linear model, then we would just use y equals mx plus b and fit this. But depreciation of a vehicle typically loses a lot at first, and then the loss kind of chills out. For example, my car will lose a lot less value this year than it did in the beginning. So if you kind of look at this, if you look at the loss over the first to the second year, you're going to have that much. However, the loss from the third year to the fourth year, not so much. So again, that's the classic shape, form, characteristic of an exponential function. Okay? Now, let's go for it. So again, we're going to use this form. So for the value of 1/15,000, we're going to get 15,000 equals A times B to the first power. All I did was put 1 in for X and 15,000 in for Y. For my ordered pair for 6,500, I get 6,500 equals A times B raised to the fourth power. Now, 15,000 Now we're going to do some tricks here. If we have two sides equal, we can show that we can look at them as a ratio equal to a ratio. Something you can show very, very, very easily. We can also show that we can flip these to get this. Now, is that legal? I don't know. 1/2 is equal to 5/10, right? Is 2/1 equal to 10/5? Absolutely. All right. So what we could do now is we can, whoa, that's not cool. We can cancel the A's to give us 6,500 over 15,000. Now, how do we handle this? How do we handle B to the fourth over B to the first? Well, guys, what we do there is we subtract the exponents, 4 minus 1, to get B cubed. Now, we're going to do a little tricky business here now. What I want you to do now is I want you to raise this power to the inverse of 3. So we're going to raise it to the 1/3 power. When we raise a power to a power, we multiply. 3 times a third gives me 1. So ultimately, I'm going to have B to the first power on the right-hand side. But guys, in equations, if I do something to one side, I have to do it to the other side. So cleaning everything up, I get 6,500 divided by 15,000 raised to the 1/3 power. All right, now I'm going to show you how to do this in your calculator. And if we go to the calculator, so let's go second function quit. Get back to the home screen. Guys, I just like to clear everything out. Okay, yeah, this thing takes up a lot of memory. Okay, so what I would want to do here is I would want to go left parentheses, 6,500. Divided by 15,000. Huh, okay. Wow. All right, right parentheses. Now, I've got to raise to a power, and to do that, I use this key right here, the one that just turned red. And I want to raise that to the 1/3 power, so I want to put the 1 divided by 3 in parentheses. And then close it up. Because if you just put the 1 divided by 3, this calculator would be fine the way this operating system works. But some calculators, if you don't put the 1/3 in parentheses, it'll raise it to the 1 power and to divide everything by 3. Now you get into an order of operations problem, which is not cool. Okay, let's hit enter. So gang, the B value that we get is 0.75. I'm writing it over. So 0.7567. I'm going to go out to about 4 places. Okay. Now I'm going to close this down because this is really, well, nah, let's just leave it up, and the video will just take a little longer because it takes so long to do anything here. All right. So what I've done, I've written down the answer there. Now what I'm going to do is I'm going to go back and get one of my ordered pairs, and I see no reason not to use this one. And I'm going to put in the information realizing that my B value is 0.7567. And I'm going to solve for A. So guys, remember I have y equals A times B raised to the x power. So y is 15,000. My A value is unknown. My B value is 7.7567. And my x value is conveniently equal to 1. So guys, all I need to do now is divide both sides by 0.7567. And, you know, if you want, raise to the first power. So this is equal to B. So I'm just going to grab my calculator and do this. So 15,000 divided by 0.7567. So B is going to be equal to 19,822.92. Alrighty. Now, so ultimately, guys, what we get is we get that the value y, and I'm going to clean this up in just a second, A times B to the x power. So guys, in this problem, our y is value of t. So value of the car equals A, which was 19,822.92. And our B value was 0.7576. Raised to the x power, I think. Yeah. All right, let's go back to the handout. So guys, this is going to be the answer to part A. So these things are a little bit harder to get than the linear functions. Take a little bit more work, but actually take a lot more work. Okay? All right, part B says use your equation to predict the value of the hybrid 10 years after it was purchased. Well, at the end of the day, what we're asking to find there is just v of 10. So I'm going to cheat a little bit here, gang. And what do we need to do in part B? We need to put 10 in for x and 10 in for x. So our answer, 19,822.92 and 0.7567 or 0.7576 raised to the 10th power gets a value of not much. So we got $1,234.72. Now, I'm going to cheat again in part C. What was the purchase price? Okay, so part C, purchase price would be the value at t equals 0. So we put 0 in for x. And guys, there's a well-known fact, and you can verify this using your calculator, that anything raised to the 0 power is just 1. So the value you see here for 19,822.92 is kind of the intercept. Well, it's not kind of the intercept, it is the intercept. It's the value when x, t, q, whatever it may be, is equal to 0. Now again, verify that on your calculator. Put in a number, 5.2, just so you don't think anything's tricky. Raise it to the 0 power, and you'll see you get 1. So it really doesn't matter what you get, what you put in there. Anything raised to the 0 power is equal to 1. So obviously 1 times 19,822.92 is 19,822.92. All right, gang, that's it. Hopefully you were okay with the videos. Again, I did it because we won't have class on the 28th, which is the birthday of yours truly. I think my daughters have some stuff planned for me. So, and you know what? If we met in class, this would be exactly the same lecture I would have given you. So, there's no integrity lost in the course material. So, guys, have a good one. I will see you on Monday. I think that's June 2nd. So, have a good one.